Hi, good morning. So today we're going to talk about how to do GCF factoring. GCF stands for greatest common factor. Alright, so when you are GCF factoring, you want to first make note of how many terms you have in your expression. So for this first example, there are two terms. Terms are going to be things that are separated by a plus or a minus sign. This is 42k plus 7. So then there's two terms, 42k and then the 7. Alright? So again, for GCF factoring, right, and then the C stands for common. So you want to look at both of your terms and see what factor do they have in common. Meaning, is there a number that goes into both numbers, 42 and 7? Again, we also want the biggest, right? And that's what the G stands for, greatest common factor. Okay, so between 42 and 7, the biggest number that goes into both of those is 7. Okay, so once you found your GCF, we're going to write that down. Now, we're not going to write a k next to that 7. Okay, well, k is part of this term. This term does not have a k. Okay, so our GCF, again, which is we write right here, right, is 7. Now, next to your GCF, you're going to open up a set of parentheses. And inside, we're going to write down what is left over when we take out the GCF. And what I mean by taking out is we're going to take this term, each of these terms, and we're going to divide it by the GCF. Okay, so we're going to do 42k divided by 7, or 42 divided by 7 is 6, and then the k is going to come along for the right. Okay, we'll bring down this plus sign. 7 divided by the GCF of 7 is 1. Okay, so here's our final answer. Alright, there we did some factoring with GCF. Take a look at number 2. Again, you're looking at both terms. There's two terms here because there's only one plus sign. There's two terms. So again, we want to try to find the biggest number that can be divided into both of these numbers. Negative 27 and positive 36. Right? And the biggest number is 9. Right? Because you can take 27 divided by 9 evenly, 36 divided by 9. Again, we're looking for the biggest. Alright? Now, some of you may have thought maybe 3. Well, 3 does go into 27, and 36. It is not the greatest or the biggest common factor between these two numbers. You have to have the greatest, the biggest. Okay? Now, because this lead term has a negative sign, our GCF is also going to have that negative sign. Okay. Now, we're not going to stop there for our GCF, because unlike the first example, both these terms have the variable p as well. Right? Remember, this term had a variable, this term did not. Okay, but here we have two terms that have that variable p. So that means p is going to be part of our GCF. Right. So not only are we going to have a number part to our GCF, we're also going to have a variable part to our GCF. Right? Because both our terms have that same variable. Now, we got one more thing we need to look at, and that is the exponents to those variables. Alright, so this one has a 7, and this one has a 6. So when you're trying to decide in your GCF what exponent is your variable going to have, it's always going to be the lowest exponent number. Okay, so again, if you have more than one term with a variable and an exponent as a GCF, you're going to bring that exponent as part of your GCF, and the exponent is going to be the smallest exponent that you have. Okay, so here's our GCF for both these two terms. So now in parentheses, right, are going to be our leftovers after we take each of these terms and divide it by our GCF. We get negative 27 divided by negative 9 is a positive 3. We got p to the 7th divided by p to the 6th. Okay, so now again, if you think about what we went over last week with exponent division, alright, again, it's p to the 7th divided by p to the 6th. The rule is we keep the variable and we subtract top minus the bottom exponent. 7 minus 6 is 1. Bring down the plus sign. Now we're going to do that division again. So this time we're going to do 36 divided by negative 9. And that's negative 4. And we got p to the 6 divided by p to the 6. Well, anything divided by itself is 1. So I could put times 1 here, but again, you know, we don't need to do that. So that means we're done. So here is our factored, GCF factored answer. Okay, let's go on to number 3. All right, gotta pick up the pace a little bit. So we're looking at two terms again. I got a 6 and a negative 30. The biggest number that goes into both of those is 6. They both terms have a variable in it, so we know there's going to be a variable in our GCF. But the exponent we're going to attach to that variable is going to be the smallest exponent of the two. Alright, so we'll put parentheses. So now we're going to do 6 divided by 6 is 1. X to the third divided by x squared is x to the first. Negative 30 divided by 6 is negative 5. And x squared divided by x squared is 1. Alright, and we don't need to write that. So here's our final answer. Alright, so now we're going to move on to examples that have 3 terms. Okay, so 1, 2, 3. There's 3 terms here. So now again, we have to look at all 3 terms. Remember, this is GCF, greatest common factor, for all the terms in your expression. Okay, so now we have to look at 3 terms. I got a 25, and a negative 10. So we got to think about what is the biggest number that we can divide into all 3 of those numbers. Right? And that number is 5. Right? 5 can go into 25, and 5 can go into 10. That's the biggest number. Right? We can't say 10, right? Because 10 does not go into 25. You can't do 25 divided by 10. Okay, we can't say 25 because in 10 you cannot divide 10 by 25. Right? So again, we're trying to find the biggest number that goes into all of the terms. Because our lead coefficient is negative, we're going to have a negative for our GCF. Alright, so now we're thinking about a variable. Alright, there's an n here, an n here, but this one does not have an n. Okay, because this last term does not have an n. We are not going to have a variable for our GCF. Because remember, it has to be common for all the terms. And not all the terms have an n, so my GCF is not going to have an n. So we're going to start to open up our parentheses, and then we're going to start dividing. Negative 25n cubed divided by negative 5 is 5n cubed. 25n divided by negative 5 is negative 5n. Negative 10 divided by negative 5 is a positive 2. Okay. Alright, so at this point I want you to pause the video and I want you to see what you can do with problems number 5 and 6. So go ahead and pause it right now. Waiting for you to pause. Pause it. Okay, so for number 5, looking at all 3, the numbers are 3, 4, and 4. Right, there is not a number that you can divide into all 3 of those numbers evenly. Okay, so I'm not even going to, you could put a 1 there if you want, but again, number-wise, it's just, that's the GCF. Variable-wise, again, they all have an x in it, so we're going to have an x as part of our GCF. Right? But then the exponent attached to it, or if you don't see an exponent, there's a 1, is going to be a 1. We're always taking the smallest exponent as part of our GCF. Alright, so then we divide. 3x to the first divided by 1x to the first is 3. 4x squared divided by 1x, 4x to the first. 4x cubed divided by 1x, 4x squared. Okay, so for number 6, alright, you should have found your GCF to be negative 4a to the first. Negative 4 is the number that goes in all 3 of these numbers. And since all of them have a's, we're going to have an a as part of our GCF. And 1 is getting the smallest exponent, so that's the exponent we're going to have for our GCF. Then we find what's inside the parentheses by taking each of these terms and dividing it by the GCF we figured out. Alright, finish off here with the last 2 examples. Here we have 4 terms. Now again, we're looking for what they all have in common. Got a 16, a 16, a 12, and an 8. Alright, I can't pick 8, because 8 does not go in a 12. I can't pick 16, because 16 does not go in a 12 or 8. Alright. Our GCF here is 4. 4 is the biggest number that goes into all 4 of these numbers. They all do not have the variable k, so our GCF is just going to be that 4. Alright, we figure out what's inside the parentheses by doing dividing. 16 k cubed divided by 4 is 4k cubed. 16k squared divided by 4 is 4k squared. 12k divided by 4, 3k. 8 divided by 4 is 2. Okay, so again, we're dividing by the GCF. This is how we're getting these numbers in the parentheses. We're dividing by the GCF. 4 terms here. Looking at all the numbers, there's a 3 they all have in common as a GCF. That 3 can divide into all of these numbers. They all have n's, so our GCF is going to have an n. And we're going to take the smallest exponent to be part of our GCF. Alright, so I want you to go and finish off this one and finish off number 9. So pause the video and finish off 8 and then do number 9. Alright, so when you divide each of these terms by the GCF of 3n in the fourth, you're left with 3n cubed plus 3n squared minus 2n plus 1. And for number 9, GCF here is b squared. Alright, because you're looking at 3, the 2, the 5, and the 1. There is not a number that can be divided into all of those. But they do all have the variable b, so we're going to have b as part of our GCF. And because 2 is our smallest exponent of those, we're going to put 2 as part of our GCF. Alright, I'm going to take each of these terms and divide it by b squared. 3b to the fifth divided by b squared is 3b cubed. Negative 2b to the fourth divided by b squared, negative 2b squared. Negative 5b cubed divided by b squared, negative 5b. b squared divided by b squared is 1. Okay? Alright, so that's it for today. If you have any questions, please let me know.